In this video, we are going to find the relation between energy of the incident radiation or energy of any radiation and its wavelength. Suppose if there is a wavelength or an electromagnetic radiation. This is an electromagnetic radiation. Its frequency is nu, its wavelength is lambda, its energy is E. So we know that according to quantum theory, E equal to h nu. So the velocity of any electromagnetic radiation or wave is the product of frequency and wavelength. Hence, frequency can be written as c divided by lambda. This one we are substituting here. So we are getting energy equal to h into c by lambda. H is the Planck's constant. It is 6.626 into 10 power minus 34 joule second. And c is the velocity of light. So 3 into 10 power 8 meter per second whole divided by lambda. The second and second will be cancelled. So you're basically having E equal to 3 into 6.626 into 10 power minus 26 joule meter by lambda. Here let me keep lambda and E. I'll just convert joule into electron volt because energy of the radiation is in the electron volts, but this is in joule. So I'm trying to convert. What is it? 1.6 into 10 power minus 19 joule is equal to 1 electron volt. Hence 1 joule is equal to 1 electron volt divided by 1.6 into 10 power minus 19. So in place of joule, I'm going to substitute this here. So basically E equal to 3 into 6.626 into 10 power minus 26 into, in place of joule, electron volt by 1.6 into 10 power minus 19. This lambda is as it is and meter is there. So when you calculate the value of this, you get 1242 into 10 power minus 9 electron volt meter by lambda is there. So this 10 power minus 9 meter is nanometer. So 10 power minus 9 meter is nanometer. So I am writing this as energy equal to 1242, that electron volt be as it is, and 10 power minus 9 meter becomes nanometer by lambda. So if you substitute lambda in nanometer will be cancelled. You get energy in electron volt. Or if you want lambda is equal to 1242 electron volt nanometer by energy E. So the application of this in photoelectric effect and other things I will discuss in the next video. But suppose you want to find the energy of a radiation of wavelength 6000 angstrom. What is its energy? If you want to find out the energy, you have to substitute lambda in nanometer. So 6000 angstrom means into 10 power minus 10 meter. If you cut 1 0, it becomes 10 power minus 9 meter. So 6000 angstrom is 600 nanometer. So you have to substitute this in nanometer to get the energy in radiation, electron volt. So this energy of the wave is equal to 1242 electron volt nanometer by 6000 angstrom is nothing but 600 nanometer. So it is 600 nanometer. Nanometer will be cancelled. This divided by this 2 zeros, 12.42 by 2. So energy is equal to 2.076 or 42 electron volt is there. So like that you can find energy. If you know the wavelength, you can find the energy of the wave, or vice versa. Suppose if there is a energy level, energy difference between the energy level is 4 electron volt. If electron makes a transition from here, what is the wavelength of the radiation emitted? If that is asked, lambda is equal to 1242 electron volt nanometer by a wavelength, the energy difference between the orbit is 4 electron volt. So it is 4 electron volt. When I cancel these two, electron volt will be cancelled. So it is lambda equal to, so it is 3 times 1 times and then 0 times 5, so it is 310.5 nanometer or 3105 angstrom. So if you push this digit once to the right, it becomes angstrom. So angstrom to nanometer, one digit I mean 10 less, and or 1 decimal point less, and nanometer to angstrom 1 decimal point more. So the application of this important formula I will discuss further in the 2-3 subsequent videos. Just remember these two ones.